Hello, I'm Adam Davis, and today I'm going to talk to you about Groovy Reactive Streams using Reactive Stream libraries from Groovy. So you may be familiar with existing models of concurrency using the synchronized keyword. The future is an executor service in Java. Other concepts like software transactional memory, actor-based model, and then reactive streams. So these are all different approaches of tackling the same problem, which is running things concurrently, running multiple threads and taking advantage of a machine with multiple processors, and at the same time you want to take care of things like networking and user interactions. And reactive streams are one approach to this, and they're built on an open API known as the Reactive Streams API. And there are four core components to this API. The publisher, which pushes out the data; subscriber, which reads the data; processor, which implements both of those interfaces; and a subscription, which is a link between the publisher and subscriber. And the subscriber uses this to request a number of values or can cancel the stream. The main difference in reactive streams between these other models is the ability to handle back pressure, which means because the subscriber is requesting a certain number of values, you can handle things where the downstream or the subscriber cannot handle too much data. In other words, it controls the amount of data that it's receiving. And what this does, it avoids a lot of issues that you might encounter without the ability to handle back pressure, such as memory overflows, or taking up 100% CPU and crashing the system. So that's important. So what are streams? They take on many different names depending on which library you're using that implements the API. They might be called an observable, flowable, a flux, or a source. These are all similar concepts. There may be some differences there. It's asynchronous, and as I mentioned, can handle back pressure. So common concepts between all reactive stream libraries are the concepts of course, the stream. There's a concept of hot and cold, and methods like filter and map, which I'll talk about. So the difference between hot and cold: hot means it's something that is always going on, such as user input or weather data, something that's a reading or input to the system, that as opposed to cold data, which is something that's recorded or something that you're getting from a database or is hard-coded into the system. Now, when using reactive streams, everything can be converted into a stream, and that is the entry point to the library. So that's, in other words, that's how you would, when you start using it, your mindset has to convert everything into a stream, including even if it's one item. So we'll get to some examples later. The common concepts are filtering. So the filter method only matches a certain predicate and then passes the data along the stream. So here I'm using different colored shapes. The top line represents the incoming stream, and the bottom line on these graphs represents the resulting stream, or the outgoing stream. So after filtering here, I'm saying filter only stars, and then returning only the stars. Here I'm mapping from circles to squares, and you'll see that. And then flat map takes in, uses a function which converts the incoming items into a stream of additional items, and then the word flat means it outputs only one stream. So here you can see it taking a star and converting it to two circles. Now, since we're talking about Groovy, the equivalent methods in Groovy are find all, is similar to filter, collect is similar to map, and flat map is similar to collect and then a flatten method call. And of course there's for each, and is equivalent to each in Groovy. Now, common concepts in Reactive Streams that might not be present in Groovy are like delay, which delays, that's a time-based method that will delay inputs a certain amount of time. Buffer, which takes in a time frame, and then within each time frame it creates a block of items, and then those items are emitted as a list, for example, into the output stream. Take while actually will terminate a stream when the given predicate is not true anymore. So here it's saying take while the shape is a star, so when you get a circle it then terminates the stream. And a similar method, take in, which just takes some number of items, which is similar to sublist, or in Groovy the range operator using the bracket operation. These others, when you're handling back pressure, you might use latest or debounce or throttle first, or different methods, which means they, for example, debounce will only return an item after a certain quiet period of time. In other words, no input is coming for a certain period of time. And throttle first, similar, it takes the first item and then is quiet or ignores items for a certain period of time afterwards. So that's useful for noisy inputs, like you might take mouse clicks, for example, or an iPad touch input, or something like that, where you want to, if there's multiple inputs within a very quick period of time, you'd want to just take the first one and ignore the rest. So I'd like to do a demo. Okay, so first we're going to take a look at Groovy. Actually, first we're going to take a look at just plain old Groovy. So just to get a base understanding of what we're talking about here. So this is just a plain old Groovy script. I'm grabbing this library I made called Shapes, which just creates, I can show you what that is. Shape is an enum, and it has a star, square, circle, triangle, and rectangle. And then it has some methods saying which one, determining which one it is. A multiply method, which creates a shape with a color on it, and a method called a static method, a random shape, which creates a random shape. Basically just creates one, pulls out one of these enums. So we'll show, I'll give you an example of why I'm doing that. First I'm going to run this Groovy script, which takes in random shapes here, prints out the original list, then I'm finding all of the stars, pulling out the first three, then I'm mapping it to the toString value, adding it to a list, and then eventually I'm going to print out that list. So let's see what happens here. So you'll see here it's printing out the original array of shapes, which is just a random shapes with random color. And because I did find all of the stars, it should find all the stars and then print out the first three. And that's what comes out here. So let's see, there's a yellow star, so that's this one. A blue star, that's going to be this one. And a purple, which is this one over here. So this is just an example. You can imagine this could be some sort of weather data that you're reading, or it could be user inputs that are coming in. And although right now they all come in at basically the same time, there could be time associated with these as well. In other words, these could be coming in every second or some random number of times. You don't know when the data is coming, but you can still deal with it. So, of course, in Groovy, we don't have a direct way of making this multi-threaded. But if we go here using RxJava, we're going to do essentially the same thing, but subscribe on using schedulers from RxJava. We're going to set the initial thread to use the single thread. Then I'm using filter, take3, mapping it to a string, and subscribing and adding it to the list, so it does essentially the same thing. So I'm going to run that. We'll see what happens here. So I do the same thing. I'm taking the first three stars. I have a red, green, and a blue here. And then the other thing I'm doing is I'm printing out the threads that I'm using. So the name here, I'm getting thread 1 from within my filter method, and thread 2 from here, where I'm calling do on next. So here I'm just demonstrating that the first thread is from the Rx single scheduler, and the second thread is from the computation thread pool, because here I call observe on with schedulers.computation. And what that does is set all of the methods called downstream are going to use that scheduler. So in other words, here the map and the do on next and the subscribe should all be using the computation thread scheduler. And of course, all these different schedulers can be used for different purposes. In this case, you'd want to use computation thread scheduler if you were doing some heavy computations, which of course I'm not doing here, but imagine that instead of toString, I'm doing a lot of computation here. And this enables you to utilize all of the processors of your machine when you use this in the correct way. So we'll get into that a little bit later here. Because this is one flowable, it's still going to use just one thread, but if you have multiple flowables, it will take advantage of those threads. So next we'll look at Project Reactor. So first I grab my library, and from Project Reactor I'm grabbing Reactor core with the version here, using Groovy grapes. And then I'm doing the same thing, but using a flux from Reactor. So you can see here in the imports, I'm importing flux and schedulers from the Reactor project. So let's run this. So here you got your random shapes, And then you got the stars that I filtered out, the first three. And then again, I'm printing out what threads here. You can see here that the naming process is different for Reactor. Here it's called single-1, and instead of computation they have something called parallel scheduler, which is similar. And so here I'm using parallel.1. Instead of observe on, the method is called publish on. So Reactor is somewhat similar to RxJava, with a few differences here and there. And then I forgot to mention here, I'm sleeping for 300 milliseconds due to the fact that these are running. All of this is running in a separate thread or multiple threads. So in order for that to finish, I have to sleep. So there's other ways to do that, such as here I could use the immediate scheduler to make sure that instead of using separate thread, it's subscribing on the current thread. But here I'm just sleeping for a little while to make sure that everything is complete before printing out the stars. If I didn't do that, then you might notice that it's not complete with processing. So we might just get 1 star, or in this case we got 0 stars. So we print it out, it's still empty. It's not done processing. So lastly, I'm going to take a look at Akka. Here I'm grabbing the Akka Stream library, I'm importing it, and then I'm down here doing the same thing, but in Akka you use what's called a source, and you have to create a materializer here, so I've done that. And then the methods are very similar, filtering it, I'm taking the 3, and then I'm mapping it. Then I'm gonna, and here you call run for each, calling the add method on the stars list. Finally I'm sleeping, and then I'm printing out the stars. So let's go ahead and run that, see if that works. And there you go, it works as well. So I printed out some random shapes. I'm taking these first 3 stars here, printing those out. Akka works a little bit different. If you want to go asynchronous, instead you actually call the map async, or there's also an async method directly. So you have to directly tell the source, or tell the model from Akka that you want to be asynchronous. So here if you do map async 4, that takes advantage of 4 asynchronous threads. So if I run that, let's see if that works, and that works the same. So you also notice here that I'm using completable future because this method takes actually a function that must return a completion stage interface, which the completable future implements. And that, I believe, is from Java 8 or Java 7. And that, just here, I'm just saying supply async v2string, so that this is called asynchronously using this thread. So that's how that works. So this could be any completable future here. And just imagine that this is a long running process, or it could be even some sort of I/O process, like reading from a database. Now, because this talk is about Groovy, I'd like to take a look at the differences of using Groovy instead of Java. So for the most part in Groovy 3, it'll be the same, but there are a little bit of differences. So as discussed earlier, common concepts of schedulers and for describing what kind of threading that you want to use in your environment. So here's an example in RxJava. You use a flowable. I'm using a range of 1 to 64. I'm observing on computation scheduler, and then mapping. So this is a good way to take advantage of, for example, you have a quad core. The scheduler would automatically could create 4 different threads to run your process on. In Akka, you would use map async, and in Reactor, you use publish on schedulers parallel. Right. Then in RxJava, the types are observable and flowable, which can hold 0 to any number of elements, and implements the, well, flowable actually implements publisher interface. Single is similar, but only can have single element or an error, and maybe can have 0 or 1 element or an error. In Reactor, the type is called flux for having 0 to n elements, and that is essentially a publisher. And it has a monotype for single element, and it also has an additional thing called a context, which you can use to store like side values or external values to your subscription. It's basically associated with a subscription. The other libraries don't have a similar concept to this, as far as I can tell. That's something to keep in mind. Akka Streams has a source, which is sort of like a publisher. It's not really. Sync is sort of equivalent to a subscriber. It also has a concept of a graph, which is like a static topography describing your streams. A materializer, which is what gets used when you're running a stream. You have to use a materializer, which is like an environment in which to run. The biggest difference with the other 2 libraries is it has immutable topography. So if you want to have a dynamic topography, you have to explicitly use things like the merge hub and the broadcast hub to do that. To make sure you actually take advantage of multiple threads, using RxJava, for example, you need to make sure that you create multiple flowables and then subscribe on the same scheduler. For example, here I want to take the range 1 to 64, and this could be any flowable, but then I want to take that and actually do a computation in parallel on it using the computation scheduler. So I take the value and I flat map it and create a new flowable of just that value using the just method. And I use subscribe on computation scheduler here, and then finally map the value to, and then here it would be an expensive computation. Here I'm just doing the square of that value. So by creating a new flowable here within FlatMap, you're taking advantage of multiple threads to do that computation. And then finally here, I'm calling do on error to take care of any errors. And this do on complete, so it'll run this, it'll print this out when it's completed. And finally, I'm using blocking subscribe so that it will add all the values to this list before returning from this method. So, similar way, you would do this in Reactor using a similar method here, where you would need to actually create a new, here I'm just creating a new mono, subscribing on the parallel scheduler, and then mapping that value all inside of this flat map method. And finally, I'm subscribing the immediate scheduler, and Reactor actually has a specific method called collect list, and then blocking until that returns. Okay, and then I'm just going to wrap it up here using pre-Groovy 3. You would have to use, of course, the closure syntax instead of lambdas from Java. The method reference in Groovy is different, and most of the time closure just work. But sometimes, such as when you use on-air resume next, you need to use the as keyword to cast to the specific type that you want your closure to be, because it's an overloaded method, and so it can be ambiguous in that case. And of course, Groovy 3 has a new feature, like Java 11 parity, so you can use lambda expressions and method references just like you would in Java 8 and beyond. And it also has support for the var, well, not keyword, but the variable declaration using var, and it has new features such as not in, not instance of, Elvis assignment, safe array get, and the triple equal sign. So thanks for listening. I hope to do some more about this in later videos. Let me know if you have any questions. This code is available on GitHub at this address, and check out, of course, me on Twitter or my website. Thanks for listening.